Hi dear students, welcome to another class of plus 1 physics. Today we are discussing a new two-dimensional motion in a plane. Can you see what I am doing? Yes, I tie a cork at the end of a string and I curl it. The body moves in a circular path. Is it one dimension, two dimension or three dimension? Definitely it is two-dimensional motion. Why? This circle lies in a plane, so therefore it is a two-dimensional motion. Then yes, what is a circular motion? The motion of an object along the circumference of a circle. The motion of an object along the circumference of a circle is called a circular motion. You can see a lot of example for circular motion. It is a universally common motion. You can say a number of examples for circular motion. The rotation of earth, the revolution of earth, the electrons are revolving around the nucleus, circular motion. The handles of clocks move in circular motion. Okay, you can see a number of examples in our daily life. In circular motion, if the tie break, what happened? The cork will move tangentially. The cork will move tangentially. That is, actually the direction of cork is tangential. At any instant in the circular motion, at any point of the circle, if it is move, if the tie break, it will move tangentially. That is, the direction of the cork is tangential. But it does not move tangentially. It move in circular path because there is an acceleration. There is a constant acceleration throughout the motion called centripetal acceleration. Therefore, the velocity is not constant. In circular motion, the velocity never becomes constant. Velocity always instantly changes velocity because the direction always changes. Then what is uniform circular motion? You heard uniform motion in one dimension. What is uniform motion? The velocity is constant. But in circular motion, velocity always changes, instantly changes, because instantaneous acceleration is there. Then uniform circular motion represent the motion of circular motion with constant what? Constant speed. Speed does not depend the direction. It is a scalar. Therefore, uniform circular motion represent the motion of an object along the circumference of a circle with the constant speed. If the speed of a body in circular motion is constant, we can say it is in uniform circular motion. Okay, for example, handle of a clock, second hand, minute hand or hour hand. It is in uniform circular motion. Okay, speed constant, but velocity changes because the direction always changes. Okay. Now we can check some important terms related to circular motion. First one, time period or simply period, T. Period of a circular motion. Consider circular motion. In circular motion, we have a center called origin, or we have a radius. In two dimension, we call radius vector. Okay, two dimension radius is not a constant, its direction changes. So it is at a radius vector R. Suppose the body start moving from here, the point P, from P, and it moves in anti-clockwise direction and return to P. The time taken to complete one revolution is called time period. If it starts from P and return to P, then one revolution completed. The time taken to complete one revolution is called a time period. Time taken to complete one revolution is called a period of uniform circular motion. It is represented as T. Unit time. So it is unit second. Unit second. Next term, frequency, very important. Frequency. You heard frequency? Yes. Frequency we can represent F or mu. Now we represent F. Frequency is number. How many times is revolved in 1 second? The number of revolution in 1 second is called frequency. What is frequency of circular motion? The number of revolutions in 1 second is called frequency. Okay. What is the relation between frequency and time period? Suppose a body revolve 2 times in a second, 2 times in a second. What is the frequency? Frequency F is equal to 2. What is the time period? 2 times in a second. Then for one revolution it will take half second. 0.5. Isn't it? Yes. If F equal to 10, what's meaning? The body revolving 10 number per second. In 1 second it revolve 10. Then what is the time period? Yes, it is 1 by 10. 1 by 10 time taken to one revolution. Then you can say F equal to 1 by T. Frequency and time period are related as reciprocal. F is equal to 1 by T. F is equal to 1 by T, or T is equal to 1 by F. This is the relation between time period and frequency of revolution. Okay. The unit of frequency is hertz. Hertz. We represent Hz, hertz. Also we can say cycles per second, because 1 by T, unit of T, second. Okay. But cycles per second, revolution per second. Okay. That is called hertz. Okay. If we know the time period, we can find out the frequency. If we know frequency, we can find out the period. Yes. Now, another term, angular displacement. It is very simple to study circular motion compared to straight line motion. Put at angular. Okay, angular. You already know what is displacement. What is displacement? The shortest distance. Okay, the distance between initial point and a final point directly. Now angular displacement means the angle swept by a radius vector. Suppose we consider a circular motion. This is the radius vector r1, and it moves from P to Q at a time delta t. The radius vector reaches at P. If the body moves from P to Q, the radius vector r1 changes its direction from r1 to r2. Okay, all are vectors. We consider both magnitude and direction. Radius vector, magnitude is same, but direction changes instantaneously. Okay, that is the angle swept by the radius vector is called angular displacement delta theta. Angular displacement delta theta is the angle swept by radius vector. angle swept by radius vector is called angular displacement, delta theta, okay, or theta. Linear displacement we denote x. Instead of x we use angular displacement theta, delta x, or here delta theta, okay. Next, angular velocity. You study angular displacement. Next, angular velocity. Angular velocity. Put the term angular before the linear terms. Angular velocity. We represent it as omega. It's read as omega, not W. Omega, Greek letter. Okay. Angular velocity, very, very important term. It is the, what is velocity? Rate of change of displacement. Rate of change of displacement in one dimension. V is equal to dx by dt or delta x by delta t. We can write in differential form like this or in this form. Both are same. Okay. For instantaneously we write this term. Put the limit and in the form of differential. Okay. We can say V is equal to delta x by delta t. It is the rate of change of displacement. Same, the angular velocity is the rate of change of angular displacement. Angular velocity is the rate of change of angular displacement, delta theta by delta t. Okay. That is omega equal to delta x, delta theta by delta t. Rate of change of angular displacement, or we can write omega is equal to d theta by dt in differential form, d theta by dt. If the angular velocity is instantaneous, we can call the omega equal to d theta by dt, instantaneous velocity. Put, okay. Now, what is the unit? What is the unit of angular displacement? Angular displacement, angle. Unit of angle, radian. You already studied in unit and measurement. Then angular, this the, what is the unit of omega? Angle by, okay, angle by second. That is angle per second. Sorry, angle. What is the unit of angle? Radian. Radian per second. Radian by second. That is radian per second is the unit of angular velocity omega. Angular velocity omega, radian per second. We can also define a uniform angular velocity, instantaneous angular velocity, average angular velocity, etc. like analogous to uniform motion, okay, straight line motion. It is linear, here it is angular. Circular means angular. Next, angular acceleration. Angular acceleration. You know acceleration? Yes. Angular acceleration denoted by the letter alpha. Angular acceleration alpha. It is the rate of change of angular velocity. What is acceleration? Acceleration is the rate of change of angular is the velocity, rate of change of velocity, dv by dt or delta v by delta t. Like that we can write alpha equal to delta omega by delta t. Angular velocity is the ratio of angular acceleration is the ratio of angular velocity by time. It is the rate of change of angular velocity. This is angular acceleration. Also we can write d omega by dt. D omega by d for instantaneous value. We can say average angular acceleration, instantaneous angular acceleration, etc. Okay. The unit of angular acceleration is unit. What is the unit of angular velocity? Radian per second. Radian per second. And one more t here, that is second square. Radian per second square. This is the unit of angular acceleration. what is the relation between omega and alpha? You have to find. Relation between omega and alpha. Omega and alpha. We know. Okay. Before that, we can find the relation between V and omega. What is the relation between can you read? Any difficulty? Relation between, this is read as between. What is this? WRT. With respect to is between. This is that is. I think you know. Relation between linear velocity. What is linear velocity? V. And angular velocity omega. The relation between linear velocity v and angular velocity omega, we can derive a relation. Just look. Suppose a body in circular motion. This is the center represented as O, and this is radius vector r1, this is radius vector r2. Simply we can write the magnitude as r. Okay. This is the angular displacement delta theta. Delta theta. Okay. What is the direction of velocity? Tangential. If the body is at here, the velocity is tangential. Tangential means a tangent to the point. If the body is at here, what is the direction of velocity? Tangential to here. The magnitude is same, the length is same, but the direction changes. This v1 you can write, this is v, this is v, this is v dash. First velocity, second velocity. Okay. Yes. Suppose at delta t time the body moves from P to Q. This is the arc. We can take arc length as delta x. We know the relation between arc and radius. Angle, arc, radius are related in a circle. Arc length equal to angle by radius. Angle is equal to arc by radius. That is, delta theta can be written as delta equal to delta x by what is radius? R. Delta x by r. We got an equation. Equation number 1. Divide the equation 1 throughout by delta t. What we get? Delta theta by delta t is equal to delta x by delta t into r in denominator, delta x by delta t into r. What is delta theta by delta t? Delta theta by delta t, rate of change of angular displacement. This is called angular velocity, omega. What is delta x by delta t? Delta x by delta t, rate of change of linear displacement called linear velocity, dx by dt. That is v. We also have r in denominator, that is v by r. That is omega equal to v by r, or v is equal to r into omega. The relation between v and omega. Okay, very, very important relation. Please note, please write in your mind, it is using throughout in physics. V is equal to r omega. V is equal to r omega. Okay, we can find some special cases in the coming chapters. Simply we can say v is equal to r omega. Actually it is, these three terms are vectors. We can write in vector form. Now we write only the magnitude. V is equal to r omega. Linear velocity equal to radius into angular velocity. Linear velocity equal to radius into angular velocity. That is, if the radius of the body changes without changing omega, omega does not changes, but the radius r changes, then what changes? The velocity. If the radius increases, the linear velocity also increases. If the radius decreases, the linear velocity also decreases. Okay. Yes. Last we got v is equal to r omega. Now the relation between angular, the relation between omega and alpha, angular acceleration and angular velocity. We have v is equal to r omega. Differentiate on both sides. Differentiate on both sides. dv by dt with respect to time, wrt, with respect to time. Okay. Differentiate the equation. V is equal to r omega on both sides. We get dv by dt equal to d by dt of r omega. We take only magnitude, then r is constant, so we can say dv by dt equal to r into d omega by dt. We can take the r outside from differential. What is dv by dt? What is dv by dt? dv by dt is the acceleration here. R into what is d omega by dt? d omega by dt is the alpha angular acceleration. Then what is the relation between a and alpha? A is equal to r alpha. The relation between linear and acceleration and angular acceleration is equal to r alpha. It is also an important equation. Note. Okay, write in your mind. All you feed in your mind, not in book. Okay, book is just for reference. You read for to put in mind. Yes, good. Now an important topic, very important topic. Listen very carefully. You know, in circular motion there is an acceleration, so the direction changes at every instant. That acceleration is called a centripetal acceleration. we can show how it is called centripetal. Why it is called centripetal? Centripetal means center seeking. The word meaning center seeking. So we can show why it is called center seeking, centripetal, and what is the magnitude, what is the direction, etc. Okay, let us see. Centripetal acceleration. Centripetal acceleration. Very, very important topic. It is a 3-mark question in your board exam. Centripetal acceleration. Suppose the figure is very important. Please note how we write the figure. Figure score more mark than derivation. That is the importance of this diagram. Okay. Thus, a body in circular motion. This is the center, represent O, and the body is at A. At A, and the velocity is tangential, represented V. It is a vector, and the radius is also a vector R. Now it moves this direction, that is anti-clockwise direction. After a time delta t, it is swept an angle delta theta, angular displacement, and at the second point B, the direction is tangential to B. We can write. Please note an important point. When we draw the tangent in a circle, the tangent is always perpendicular to radius. The tangent is always perpendicular to radius. So if you draw the figure, you note the point. This angle 90 degree, this angle 90 degree. Then only this radius and this tangent become correct. Okay. Yes. This is the velocity v, and now the velocity direction changes, so we can denote v dash. Both magnitude same length, but direction is direction towards this, and this direction towards this left changes. So I denote this is v and this is v dash. Also this radius also changes, direction changes, so second radius vector can denote r dash. Okay. Now you know triangle law. What is triangle law? Suppose one vector is v, there is another vector, we add the another vector and we get the final vector in opposite direction. Suppose this is v, initial velocity, this is v dash, final velocity. Then what is this? This is the change in velocity. Another example. Suppose this is the initial position vector r. What do you mean by position vector? Here we call radius vector. In 2 dimension, the displacement is represented by a vector called position vector. It is drawn from origin. It's called the This is the origin is called a position vector or radius vector, or this is another radius vector r dash. Use triangle law. This is r. This is the change in position vector delta r. Add the initial position vector and change in position vector, you got the resultant position vector or final position vector taken as the opposite order of the third side of the triangle, that is r dash. That is r plus delta r equal to final position r dash. Okay, or r dash minus r is equal to delta r. Change in position vector is delta r. Keep in your mind, I will derive the equation of centripetal acceleration. Okay. Now, I draw a vector from A to B. This is B, this is A. We can put V equal to AP and V dash equal to BQ. I draw a vector from A to B. This is R. This is another vector. Add this to vector using triangle law. We get final position vector r dash. Then what is this? AB. AB is delta r. That is r plus delta r equal to r dash. Or r dash minus r equal to delta r. Final position vector minus, or final radius vector minus initial radius vector equal to change in radius vector. That's the displacement. Okay. Yes, you note, this is r, this is velocity v, both are perpendicular because radius and tangent. Also at B, this point A and B. At B, r dash and v dash are perpendicular because this radius and this velocity tangential velocity and radius perpendicular. Yes, okay. Now we have to derive the centripetal acceleration. Let us look the figure. Okay. I draw a straight line from the center to center and perpendicular to delta r. Redraw this vector velocity v, vector velocity v AP without changing its direction and magnitude. Measure the length and without changing this place here. AP equal to its velocity v. Similarly, redraw this v dash, measure, that is same length because uniform circular motion, magnitude of velocity constant. Measure this length and take this direction. We write this vector, that is v dash. V dash equal to A and B become equal, same point, then we can write AQ, and the velocity is V dash. What is the angle between V and V dash? This also delta theta, because the changes from R to R dash and V to V dash taken the same time delta t, and V and V dash are perpendicular, R and R dash are perpendicular, so this angle also same. Now I draw a vector from P to Q. What is this vector represent? This is initial velocity and this is final velocity, isn't it? This is the initial velocity, we start from here. This is final velocity, the position changes. Okay, then we can write V dash is V plus something. What something? That is the change in velocity delta V. That is V minus V dash minus V is equal to delta V. Okay, that is, this is change in velocity delta V. This delta V change in velocity is perpendicular to delta R. Very interesting. This delta V is perpendicular to delta R. We take any 2 points in the circular motion, any 2 points P and Q, and draw this diagram. We got this picture like delta V is always perpendicular to delta R, and it is always towards the center of the circle. So we call it as centripetal acceleration. Why? The acceleration is, the direction of acceleration is determined by change in velocity. You already studied in the straight line motion, the second chapter. The direction of acceleration depends not velocity, it depends the change in velocity, because acceleration is change in velocity by time. It depends change in velocity, not velocity. Change in velocity delta V towards center, therefore centripetal acceleration is also towards the center. We prove it. Okay. Yes. When you ask to prove the centripetal acceleration is towards the center, you draw this figure neatly, carefully read. Okay. Now we have to find what is the magnitude of this vector. What is the magnitude of this acceleration? We can call centripetal acceleration as AC. Okay. Look, these triangles AQP, one triangle, OAB, second triangle. The angle between R and R dash, V and V dash, both are same. This R dash and V dash are perpendicular. R and V are perpendicular. That is, these two triangles, which are the triangles OAB and triangle APQ are similar triangles. Both are similar triangles. In similar triangle, we can apply an equation. What is the equation? In similar triangle, we can apply an equation. The ratio of side length equal to the ratio of base length. That is AB by PQ is equal to, this side has same magnitude, OA by AP. OA by AP. Okay. That is, what is AB? What is AB? Delta R. What is PQ? Delta V. Delta R by delta V is equal to what? Equal to OA by AD. What is OA? R. What is AP? V. From these similar triangles we got delta R by delta V equal to R by V. Okay. Then we can write delta V is equal to delta R by R. Yes, delta V is equal to, you feel some confusion, so I write reciprocal, delta V by delta R equal to V by R. Both are same. Okay. Now delta V is equal to delta R into V by R. Delta R into V by R. This is an equation number 1. Divide this equation number 1 by delta T in both sides. Delta V by delta T is equal to delta R by delta T into V by R. Okay. What is delta V by delta T? Delta V by delta T is the acceleration. Here we call centripetal acceleration AC. What is delta R by delta T? Delta R means displacement. Delta R by delta T. Delta R by delta T is the velocity V, linear velocity V. Okay, we can write V, also V by R. Then we can write is equal to AC equal to V into V square by R. Very important equation. The magnitude of the centripetal acceleration is AC equal to V square by R. The magnitude of the centripetal acceleration is what? V square by R. You know centripetal force. Centripetal force equal to MA. Force equal to MA. That is, for centripetal force, if a body in circular motion, it has we apply a centripetal force. There must be a centripetal force. Fc equal to m into centripetal acceleration, that is m into v square by r. This is the equation of centripetal force. You will study in the next chapter centripetal force. Then use this equation. Okay. Also, v is equal to r omega. We know v is equal to r omega. Therefore, AC can also write r omega all square by r, that is equal to r omega square. AC equal to r omega square. One more equation. What is the equation of centripetal acceleration? AC equal to v square by r or r omega square. We can use any of the equation in problems. Okay. It's a centripetal acceleration. Then you studied in centripetal acceleration, the magnitude of centripetal acceleration is v square by r or r omega square, and the direction is towards the center of the circle. Towards the center of the circle means what do you mean towards the center of the circle? Yes. Towards the center of the circle means it is radially through radius. radially. Therefore, in circular motion, we call radial acceleration in circular motion. In all circular motion, acceleration is radial. And tangential velocity is tangential, and acceleration is radial. Very important point. Note these 2 points. In circular motion, velocity is tangential and acceleration is radial. Okay, this completed. Very, very important topic. Now, one more important equation I will show you. We know what is omega? Delta theta by delta t. For one complete revolution, what is delta theta? This is the delta theta angle. For one complete revolution, delta theta equal to 2 pi, isn't it? Yes. What is for complete revolution delta t? It is the time period t. Then we can write omega equal to 2 pi by t, isn't it? Very, very important equation. But 1 by t equal to f, so we can also write omega equal to 2 pi into f. Remember this equation. Feed in your mind. Omega is equal to 2 pi by t, omega is equal to 2 pi by f. Both are important equation. Omega is the angular velocity also called angular frequency in the coming chapters. Omega angular frequency or omega angular velocity is equal to 2 pi by t or 2 pi f. The unit is radian per second. Yes. The theory part of this chapter is completed. Okay, it's a very simple chapter. First you feel some difficulties because you will studying the first time in vectors. This is completely related with vectors, but when you try to study 1 or 2 times, you will become easy. Then it is very simple chapter for you, and you can score more mark from this chapter. It's very easy for you. So you must study. The important points in this chapters are, I will once again remind, the important points are: first, from vectors, main points: 1, triangle law of vector addition; 2, parallelogram law of vector addition; and third one, the derivation. Which derivation? Analytical method. You are given 2 vectors A and B making an angle theta. Find the magnitude and direction of the resultant. This is a question. You are given no graphical vectors A and B. Just we got a question. You have 2 vectors A and B making an angle theta. Find the magnitude and direction of the resultant. Then you derive the equation of r equal to root of p square plus q square plus 2pq cos theta. If you are given a and b, then use the symbol a and b. Then we got r equal to root of a square plus b square plus 2ab sin theta. What you are given, we use that notation in the answers. Okay, then the magnitude, if you are asked magnitude, you find tan inverse. If you feel difficulty in tan inverse, you can write it tan alpha. You got the mark. Tan alpha is equal to, yes, b sin theta by, here not q, b sin theta by a plus b cos theta. Second, upper second upper, B upper, opposite side, B adjacent side, B cos, okay, opposite side. Remember these equations, very important. These two equations are very important, and also note the special cases, important 4 cases. It will make you simplifying your problems, okay, useful for your solving problems. That's the main topics. And resolution also important. It is applicable not directly. Any questions are asked from resolution, but it's very important in your coming chapters. Then the important topics are projectile motion, completely important, and circular motion also. In projectile motion, we note the what is horizontal, what is vertical. Horizontal velocity constant, vertical velocity with uniform acceleration g, and at maximum height vertical velocity is equal to 0, not complete velocity, only vertical velocity is 0, horizontal velocity always constant. And how to derive time of flight, how to derive horizontal range, how to derive maximum height, you know. Also one question, two angle for same projection, same initial velocity and same range but different angle, theta and 90 minus theta, and prove that the path of the projectile is a parabola. We also prove in the last class, okay. Then in circular motion, the important points from also remember the maximum range, equation of maximum range. When we get maximum range, theta equal to 45 degree. When we get maximum height, theta equal to 90 degree. But it is not important, because when theta equal to 90, it becomes one dimension. And then in circular motion, today we studied circular motion. The important points are: 1, what is frequency? What is the relation between frequency and time period? Important equations. Okay, one important equation is omega is equal to 2 pi by omega is equal to 2 pi by t, or omega is equal to 2 pi f. It is very important equation. Then you study angular displacement, angular velocity, angular acceleration, relation between linear velocity and acceleration, angular velocity. It also very important. V is equal to r omega. V is equal to r omega. And A is equal to r alpha, relation between linear acceleration and angular acceleration. And finally we study the centripetal acceleration, how to prove the centripetal acceleration towards the center of the circle, which is radial, and we also find out the magnitude of the centripetal acceleration is equal to v square by r. Okay, the chapter is completed. Thank you.